All right, thank you. The microphone just could not handle how awesome Google Cloud Functions are, so it's not the first time that that has happened. But welcome, my name is Bret McGowen. I'm a developer advocate at Google on the Google Cloud Platform team. I work in the New York City office. You can reach me in here on Twitter at BretMCG. So we'll talk a little bit today about serverless microservices with Google Cloud Functions. And we'll talk briefly about what is serverless, briefly about what microservices means in that context, and then we'll talk about most of this about Google Cloud Functions. We'll do some live coding demos. I'll walk you through some slides. Should be a good time. So first, we'll talk about microservices. I'm not going to dwell on this too much, since I'm sure we're going to hear a lot about this this week and at conferences before. But just at a high level, we're going to take our monolithic application, right? And the goal here is we want to split it out into microservices for a variety of reasons. So some components have different release schedules. Some components, some services are created by different development teams, and maybe they want to use a different technology stack. Sometimes you want to iterate more often. You want to release less often. There's just different needs of these services, right? That's just kind of the idea behind microservices. But with that comes a little bit of overhead. You have to have a whole deploy process for each service. And even if it's automated, there's still process you have to put in place. You have to understand how all that works. There's just overhead. So a good way to address this is serverless. And what is serverless? Obviously, it means there are no servers. Well, of course, that's not true. There are hundreds, thousands of servers running it. It's just abstracting this all from you. So the idea is you don't have to worry about managing your infrastructure. You don't have to worry about managing your runtime. You don't have to worry about patching your OS. You just can deploy your service, and it scales automatically for you. And it is managed by someone else. So you can focus on writing your software. And there are a lot of definitions to what is serverless, and maybe what's the line between what is a platform as a service, what is serverless. And I like to think of it as sort of this shrinking point that you think about scaling. So if you just have a bunch of virtual machines in the cloud, your scaling point tends to be virtual machines. So it's your enterprise level. So all of the machines in your enterprise, that's your scaling point. And if you maybe make an acquisition or you have a new department that moves into the cloud, that scales up your resources. And then you start moving into things like containers. And so maybe you can containerize your application or a service. And then if you kind of shrink that scaling point down a little bit more to a platform as a service, which either can be one application or potentially one function. But I think about serverless as scaling at the function level, or in microservices world, sort of at the service level. And that's where you do your scaling. That's the definition I like. So we're not going to dwell a lot on what is serverless, but just to kind of give you the philosophy that I like. So let's talk about Google Cloud Functions. So this is a serverless platform for building microservices. It's right now you write them in Node.js on Google Cloud Platform. I know, Node.js. More languages are on the roadmap, but right now Node.js. And there's a few reasons we started in Node.js. One, we have a great relationship at Google with Node.js. We're on the Node.js board. And maybe most importantly, our engineers on the Chrome team created the V8 JavaScript runtime engine so that JavaScript would run very, very quickly in the browser. And for years, we've been tuning and squeezing as much performance as possible out of V8. And Node.js uses that V8 runtime to run Node apps. And of course, NPM has a huge library of functionality and modules that you can include in your application and get a lot of functionality out of the box that maybe is already written. So now let's start talking about cloud functions and their types. So there are two types. There are background functions. So these are things that respond to certain events in the cloud. So right now in Google Cloud, we support cloud storage events and then also pub/sub events. And we'll talk a little bit more about what those mean later. And then secondly, we can support webhooks. These are HTTP endpoints. And once you start talking about webhooks and HTTP endpoints, you can do things like respond to a file that's uploaded in Google Drive. Or when a new email comes in, you can respond to the attachment that's in that email. Or maybe respond to the text that's in the email. You can respond to calendar events. You can hook into ecosystems like if this, then that, which opens up a whole world of things you can have a function respond to, like your Nest thermostat temperature goes up or down, or you use something like Stripe and there's a payment event, a credit card payment event has occurred. You get a text message, and so on and so on. There's a whole ecosystem of these things that Cloud Functions makes it really easy to plug into. So let's dig into an HTTP function and what that looks like. So at its most basic level, it's only 3 lines of code, which is pretty cool. So this is the Node way of creating a function and exporting it so other libraries and modules can use it. We just say exports hello world equals function hello world request response, and then response.send, so hello London. I forgot to update that to say hello Devox. But anyway, so this is the minimum that you need to do a cloud function. And the request and the response objects are strongly typed, or at least as strongly typed as you can get in JavaScript, which means if you've done web development before, you know the request comes in with query string parameters, or JSON body, or maybe form post values, right? And the response is what you send back to the user. And you can do things like set a status code 200 to say everything is fine. And then you can actually send the text or the message back to the client. So the request, like I said, it kind of has familiar concepts to you. And Cloud Functions will actually parse those. So if you have a request that comes in with query string parameters in the URL, or in the JSON body of the request, Cloud Functions will actually parse those out and make those available to you easily. So like request.query.property_name, request.body.name. So you don't have to actually parse that JSON for you. It's really nice. And then the response, like I said before, you can just set the status code, send a response, all the normal things you might be able to do in an HTTP world. How do we manage dependencies in Cloud Functions? The same way you do in any Node.js application through package.json. This is pretty similar. You've probably seen this before in other development environments where you can kind of pin a library to a specific version, a major version, a minor version, and so forth. So, all right, that's just kind of the setup, the background. Let's dig in and do a live coding example to walk you through this. So I'm going to make an HTTP endpoint, just a basic hello world. All right, and I'm going to attempt to do the impossible, which is I'm going to start from nothing, an empty directory. So wish me luck. So first, we'll create an index.js file. Now let's open this up. And let's say exports.hello world equals function request response and response.status 200. Everything is good. Oops. Dot send hello Devox. But you know what? I've actually never liked hello world. I'm from Texas, and we don't say hello. We say howdy. So let's say howdy world and howdy Devox. Much better. All right. Feel good about that. So I can go ahead and deploy that, but let's do something maybe a little bit more complicated. So let's add a dependency here. If you've done any Node.js before, you know that I can say npm init. And this is an npm thing to create a package.json, which contains our dependencies. So this is not Cloud Function specific. So name howdy world, sounds good. Version, well, not exactly. Let's say 0.0.1. Just barely functional. Entry point, that sounds good. Test, like any good developer, skip that. Keywords, I will take credit for this. And I want this to go out on the internet and become super famous, so I will license it and make it open source. Is this okay? Yes. All right, so now let's take a look at our package.json. So this is what it looks like. We don't have any dependencies yet, so let's add one. So I'll say npm install Google Cloud Debug dash save. So this does two things. One, it installs the Google Cloud Debug library like locally in this directory, in this workstation. And then the --save means it will also add it to the package.json. So if I flip back over to package.json, you can see it's added this line here automatically. Google Cloud Debug, and it's pinned it to version 0.9.0. So let's actually use this in our application. So require Google Cloud Debug. Whoops. And let's say I want maybe this parameter to be customizable. So instead of always saying howdy Devox, I want to be able to pass in a query string parameter. So let name equals request.query.name Or if we don't give it one, then let's do devox as a default. And then we'll put it in here, name. So now if I make this request and I pass in a query string, it should say howdy, whatever I pass in. And you can do whatever you want. So I'll say mood equals request query.mood or happy. Let is weather beautiful equals false, because I was outside today and it is not. And I will say if the weather is not beautiful, then I'm going to console.error bad weather always breaks my live demos. All right, and other than that, I'll do a console.log. I made it this far with no errors. Hooray. And I pray we get to that point. All right, so there's a couple of things you can do. One, we can deploy this live, but we want to use like our natural workflow. So there's actually a Cloud Functions emulator. So I'm going to run that. So and it's just called functions. Functions deploy from this directory, howdy world. All right, so it created a local, and I want to trigger this with HTTP. So we talked about there's different kinds, ones that are triggered by storage events, pub/sub events. Pub/sub is sort of our messaging queue system in Google Cloud. But this one's just going to be triggered by HTTP, so we can call it in a browser. We can call it from the command line. We can curl it, and so forth. So you see it gives us a local endpoint. So I'm going to curl this, and it should say howdy devox. And if I give it a name equals Bret, says howdy Bret. Okay, so we feel pretty good about that. So let's do a gcloud. So now we're actually going to deploy it up into the cloud. So gcloud functions deploy howdy world. And then there's a couple of ways you can deploy your functions into Google Cloud. One of which is you can point it to like a Git repository that exists or a Bitbucket. Or in Google Cloud, we have our own like Git solution called Google Cloud Repositories. Or you can just package up the code that's on your workstation right here. So we'll just do that. So I need to give it a stage bucket. So what this means is it's actually going to zip up all the source code that I have locally on this workstation and put it into the binary blob store in Google Cloud. And we call it a bucket. So it's going to zip up all of my code and put it into the bucket that I define. And I have one here just called functions source. And then we want this to be a triggered by HTTP. All right, so while that is deploying, I want to go back to the idea that we want to use a normal workflow. So I'm in Visual Studio Code here, and Visual Studio Code has some pretty nice debugging tools for Node.js. So we just want to be able to use those. So I'll just set a breakpoint, and then add debugging configuration. That looks good. Just take the default. And I want to attach to a running process. So we're going to attach to the locally running emulator of Cloud Functions. So we've got Cloud Functions that runs in the cloud, and then we've got the local emulator that's designed just for your development purposes. But the idea is your functions look the same like on your local workstation as they do in the cloud, so it's easier to debug. So let me start this. And what was that endpoint? Do I have it? Yes. So howdy world, name equals me. All right, and it hits that breakpoint. And this is your normal debugging experience. I don't know if you've done a lot of Node.js before. This is actually like pretty nice to be able to step through in a real debugger. I know y'all in the Java world take this for granted, but it's nice and new for us. So this gives you all the normal debugging things here. So we can add a watch for whatever variables we want. We can poke around in the request object, see what parameters have come in, and so forth. So let me step through this. That all looks good. And if we go back to the command line, you can see howdy me. So one thing I do want to point out is that Google Cloud Functions will automatically map your console.error and your console.log. So these are the normal like JavaScript Node way of outputting things to the console. It'll automatically map those to the cloud logger. So you get like one place to look at all of your logs from all of your cloud functions and actually from all of your Google Cloud Platform products. So I do want to say, point out real quick, when I did that deploy, what do we get with Cloud Functions, right? So with my 3 lines of code, I mean, I actually added a few more, but at a minimum, 3 lines of code, what happened when I deployed that live into the cloud? One, we get an HTTP endpoint with a fully qualified domain, so we can hit that endpoint from anywhere in the world. It dynamically creates an SSL cert, so we can do all of our traffic over HTTPS, as we should. It gives you all the nice serverless things, like no worrying about infrastructure, scales it for you automatically. It's really, really nice, and a lot of things that we don't have to worry about, that we don't want to as developers. So I mentioned that it maps all of our logging to what we call Stackdriver logging, Google Cloud logging. And then also error reporting. So a lot of times the way we find out about errors in our application is either someone goes spelunking through the logs and dig through all of the error messages and tries to figure out what are some common patterns, or a user or an end user reports it to us, right? And that's terrible. So error reporting actually is kind of uses machine learning essentially to watch your error logs constantly, and if it sees certain patterns, it'll elevate those, and it can send those to you in an email or just through the UI in the dashboard. So that's pretty nice. So I guess we never actually hit it in production, so let's do that. So here is the deploy screen, and you can see it gives you a whole bunch of information. I'll just kind of walk you through this gcloud functions command real quick. So I can do gcloud functions list. This shows me all the functions that I have in my account. So here's the howdy world one that we just added. So gcloud functions describe howdy world. And it has a few things. So one, I mentioned, like I said earlier, if you're deploying from a local workstation, it zips up your source code. So this is actually where that zip file lives. So you need to know exactly what version of the code you're running. And then here's the HTTPS trigger. So if I do a curl on that, I should see howdy devox. Oh, and one thing I didn't do is I did not add, git commit -m. Howdy world. And then like any good developer, I'm not going to do a pull request. I'm just going to push right into origin master. And if you don't like it, you can deal with it. I promise my code is good. Yeah, that never flies. So I deployed it live. And then, yeah, so we can hit the endpoint either by curling it, or we can actually hit it in the browser. So let's do that. Let's put in that URL. Hope you can read that. I'm going to say another name equals superdevox. All right, howdy superdevox. So I do want to show you what that cloud debug package does that I just added. So it enables something called Stackdriver debug. And, whoops, let me click on the wrong thing. Since I just pushed my source code up, I can actually browse. So I have here howdy world. So here's the code that I just pushed up. Make that a little bit bigger so we can see it. And you'll notice it actually let me click here as if it were a breakpoint. Well, isn't that curious? Because, so I'm going to click on this line 7 here, this if not weather is beautiful, and I'm going to refresh. And you'll notice it highlighted that line. Well, why is that? It's because it's actually treating it like a breakpoint. So it's not a breakpoint in the sense that it doesn't stop your application from running. Like you'll see I still got my response back from the server. So instead of super devox, I'll say mega super devox. It's just getting crazier and crazier. So it hit this log point, we call it. But it's pretty cool because you have all these things you can take a look at. Name happy, mood false. You can look at the request object. You can look at the response object. And I'm doing this all in production without having to redeploy, without having to add a ton of breakpoints and a ton of log points. It's super, super powerful. And in fact, Stackdriver debugging works not just on Google Cloud, but anywhere you can run your application code. So if you're running it on-premise, if you're running it on AWS, you can actually debug this live. And of course, the next question people ask is like, well, doesn't that kill your performance? And it actually doesn't. So when you don't have, let me disable this log point. So when you don't have any log points set, there's essentially no discernible impact to the performance of your application. When you do have a breakpoint set, a log point set, there's a very minor hit, but it's essentially the same amount of hit as if you were doing a console.log, as if you were outputting some kind of variable. So it's really, really powerful for hunting things down in production without having to, I mean, we've done this before, right, where there's some weird edge case in production and you think you haven't narrowed it down, so you add a bunch of console log or a bunch of printf statements, you redeploy, you wait for that to happen, you realize, okay, well, I've made it a little further along the chain, so, but I still don't know the error, so let me add some more printfs and do a redeploy. And every time you do that in production, that's overhead and that's risk. So it's really awesome to be able to actually set these log points in production. And Stackdriver Debugger is super cool. Like I said, you can run it anywhere. In this case, I have my source code uploaded to Google Cloud, but you don't have to. You can point it to GitHub, for example. You actually can do it all locally, like right in your browser, so that no source code actually gets uploaded to Google Cloud or to anywhere. So it all happens right there in your browser. Maybe don't do it with like a 100,000 line JavaScript file, but that's pretty cool as well. So. Yes, and we enabled that production, debugging in production with just one line of code. So this was require Google Cloud Debug, and with that, we automatically got Stackdriver Debugger. I love Stackdriver Debugger, if you can't tell. I use it all the time. So now let's talk about background functions. So these are things that are triggered by events in the cloud. And the two events we have in Google Cloud Platform right now are cloud storage, which is for binary files, and then PubSub. So first we'll look at cloud storage. So how you deploy it, very similar to how you deploy the HTTP triggered one that we saw a second ago. The only difference is you give it a trigger, or you give it a bucket to trigger on. And again, a bucket is the blob storage term we have in Google Cloud. So anytime a file gets uploaded, deleted, edited, replaced, so forth, you'll get your cloud function will get triggered. And here's what that code looks like. So here we're going to analyze this image. And the function signature is slightly different. There's a context, and then there's a data. So the context is how I can report back, let me back up, how I can report back to Cloud Functions whether my function was successful or whether it failed. And then data is actually the incoming data from the event. So in this case, the file change event from cloud storage. Oops. And so what is actually in that data? I'm not going to go through all these fields, but basically there's a few things. So resource state exists. So if this file had been deleted, that event would say deleted and so forth. Content type, image JPEG, and media link down there. We'll use this, I'll reference this here in a second. That's if you're uploading a file and you made it public, this is how you would reference that file. The other cloud event we have is PubSub. So PubSub is our publisher subscriber message queuing system in Google Cloud Platform. It's fully managed. It's really, really scalable for any sort of incoming, outgoing. A lot of people use it for IoT, for example, to stream thousands and thousands of events into PubSub. And anything that's an HTTP, anything that can make an HTTP request can be a publisher and can be a subscriber. So it's a really nice way to connect all the pieces of your application. You trigger it similarly. Instead of a trigger bucket, you give it a trigger topic. So when you publish a message in PubSub, you have to associate it with a topic. When you subscribe to PubSub, you listen to a topic. So what this means is anytime something comes in under football news, I will say this is the soccer form of football, then my cloud function is going to respond. And here's what it looks like. Again, very similar. We have a context, so we can report back success or failure. And we have the data that contains the actual data that comes in that PubSub message. And PubSub is like completely customizable by you. So whatever, it's JSON, whatever JSON you put in there, you'll have access here to under message. So team name, Fighting Footballers. They exist in London, and they're currently ranked #1 in the world. So how might we put these up? How might we put these together? I don't know if I have time to do this live demo, but so I say upload a file, say this photo of an adorable raccoon. Cloud Functions would get triggered. It will take that image, it will send it to the Cloud Vision API, and we'll return back some kind of a response. So here, Cloud Vision API says this is 99% sure that it is a raccoon. and then a bunch of other different confidences. So if you don't know what Google Cloud Vision API is, super cool. I won't get into the details, but just at a high level, it does a bunch of things like label detection, which is what it just did. So you give it a photo and you say, label this photo. What is this a photo of? Is it a photo of a raccoon or a cheetah or a person? Face detection, OCR can extract text from an image. Explicit content, so it can tell you if your image is adult or violent. It can detect if it's a landmark, a famous landmark, and what the landmark is. It can detect logos, image properties, a whole bunch of stuff. And here's what the code looks like. So the analyze image function we had earlier, we're just going to require a Google Cloud Vision library. And then we're going to call vision.detect labels, and then we're going to give it that data.media link that I referenced earlier. So this is the URL, so the Vision API can pick up that image and run analysis on it. And then we're just going to iterate through all the labels and output the description and then the confidence score. So it'll look something like this. So I took this photo, so it is 92% labeled, confidence label that's black, 81% that is stage, and so forth. So I am going to ask you to do an interactive demo. Normally it's rude to text during a demo, but it would be pretty cool if you can text this number, so 32460202055. If you have a US number, it won't work, but I think if it's otherwise, you should be good. And I'll show you what this is about to do. So if you text this number, and I kept it up here at the bottom, and text how you're feeling about DevOps so far, how you're feeling about the day, the weather, Google Cloud Functions, my awesome shirt, whatever you're feeling at this moment, text it to that number. So if I texted, for example, DevOps is such an amazing event, it's going to go to Twilio. Twilio provides a webhook. So in that webhook, I pasted the URL of a function that I wrote, just like I wrote one 10 minutes ago. Exact same situation. So Twilio is going to call that webhook and into Cloud Functions. The Cloud Function is going to run. So instead of passing it to the Vision API, it's going to pass it to the Natural Language API, which is similar. It's a machine learning-backed API from Google that does a lot of things. It can analyze entities in your text. It can analyze sentiment. And so that's what we're going to do. It's going to send you back an emoji, whether you're feeling happy or sad, based on your sentiment. It's going to stream this all into BigQuery, which is Google's serverless big data analytics warehouse tool. And then it will send a response back to you with the appropriate emoji. So did anyone try it? A couple? All right. Anyone get a response? Yep. All right. Good deal. So let's actually take a look at what people send. I know that's dangerous, but. All right. So. All right. Awesome. Sure. Thank you. Howdy, bud. Traffic is as messy as this morning. Keep hanging in. So let's look at what this looks like. So this is just, what came back from the Natural Language API. So we've got this huge JSON blob, and it has a bunch of things like it says grumpy is an adjective. I'm not going to go in. I mean, this is not a talk about Natural Language API, but as you can see, it gets really. This is a huge one. Someone texted me like a giant novel. Okay, come on. But you can kind of see it basically breaks down all the entities and everything in your message, and then it gives you a polarity. So -100. So where -100 is extremely negative, like I hate everything, and 100 is extremely positive, so I love everything. So now we're going to run a query to see whether people in general wrote positive or negative things. So polarity is, all right, and 28 positive to 8 negative. All right, everyone's feeling pretty good overall. Let's see, what's another query we'll run? Anyone text any emojis? All right, just one. Well, let's see if this works. So what this is doing in BigQuery, just so you know, it's actually going to live on the fly parse all that JSON every time. This is one of the cool things about BigQuery is you can give it literally billions of rows, and it can do crazy string manipulation because it splits up your query into tons of jobs and runs them all in parallel. So you basically could run full text, full JSON parsing over literally billions of rows and get back responses in like 30 seconds, a minute. Things that might normally take a normal SQL server hours or days. So let's run this. It's not really designed to work over tiny. All right, so we got a few emojis. So we got the sweating emoji, I think that's the kissing heart emoji, the laughing till crying emoji, and then the sunglasses emoji. So thank you for doing that. I appreciate your interaction. So what did we cover today? A little bit about what is serverless, what are microservices. I walked you kind of through some Node.js development processes, how you can use what you normally use locally, and then also debug on the cloud. We walked through the different kinds of cloud functions, and we talked about that cloud functions was take your functions, scale it up, and scale it down, and manage it for you. So as a developer, you don't have to worry about any of that. That's all I have. So Cloud Functions is in alpha right now. If you want to sign up, this is a special link. It is actually an invitation-only alpha. So if you just go to Cloud Functions and sign up, you will not get in. You have to know someone. Luckily, I am someone. So if you want to take a picture of this, I can photobomb your URL. But if you want to know more, cloud.google.com/functions. And that is all I have. Thank you very much.